The definition of a surd is it's an irrational root of an integer. And what that mouthful means is that when you have a number and you get the root of it, whether it's the square root or the cubed root or the fourth root or the 50th root, usually squared and cubed roots, but when you get these numbers, you do not get a rational number. You don't get a number that can be expressed as a fraction. So, for example, the square root of 6 isn't 3 or a half or a quarter. It's an actual irrational number. And the same with all of these here. And you'll recognise them with this little sign that we tend to replace after a while to the fraction. So this here would be 6 to the power of a half. This is the third root of 12, which means what number multiplies by itself 3 times gives you 12. And that is an irrational root of a fraction, of an integer. There is no whole number that gives you, when you multiply it 3 times, gives you 12. It's somewhere between 2, because 2 by 2 by 2 is 8. And it's somewhere between that, 2, and 3, because 3 by 3 by 3 is 27. Probably a bit closer to 2 than to 3. And you get them like this as well. So it's the cubed root of 81 to be squared, and so on. Here are the rules. So let's have a look at doing some of these examples. The way you read this is, this is from the syllabus for the Junior Certificate in Mathematics, and surds are part of the number strand. So if we look at our examples here, a to the power of p multiplied by a to the power of q is equal to a to the power of p plus q. A and b are real numbers, so they're real numbers. They could be 4 or 5 or minus 6 and minus 7, or they can be pi or square root of 2. They're real numbers. But b is not equal to 0. A and b are not equal to 0. Where's my b? Is any b's here? I think they're on the next page. P and Q are elements of Q, and Q are rational numbers. Q means quotient, I think, but and a quotient is something that happens in a division, which is where we're getting this rational number from. So something that being expressed as a fraction. So P and Q are rational numbers, and a to the power of P and a to the power of Q, they're real numbers as well. But we're not dealing with complex numbers. So if we look at something like a to the power of P and 8 multiplied by 8 to the power of q, we're talking about something like the lines of 2 to the power of 3 multiplied by 2 to the power of 6. So you notice that the a is the same, so the 2 is the same as the 2. The base is the same, but the powers are different. That's going to give me 2 to the power of 3 plus 6, which is equal to 2 to the power of 9. All right? So that's that bit, how you can express it. Then a to the power of, let's look at the next one, a to the power of p divided by a to the power of q. So 2 to the power of 6 divided by 2 to the power of 4. Well, that's equal to 2 to the power of 6 minus 4, which is 2 to the power of 2. So you're just subtracting the indices. When you get a to the power of 0, that's equal to 1. Because we're just a few days before the junior cert, I'm not going to go into too much theory in this, so we just leave it. You have to just know a to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So, 6.32 to the power of 0 is equal to 1. Pi to the power of 0 is equal to 1. A billion to the power of 0 is equal to 1, okay? So, and then you get this last one, a to the power of p to the power of q is equal to a to the power of p multiplied by q. Okay, I've done these in class before, so hopefully you've got these. Next one, let's have a look at a to the power of 1 over q. And again, looking at the English, or reading the mathematics, that's equal to, we can rewrite that as the q to the power of a. So if we'll see an example in a moment. But q is an integer, so this number here on the bottom is an integer. So it's a whole number, positive or negative. But it's not 0, and a is greater than 0. So you're going to get things like the cubed root, the square root of 3 is equal to 3 to the power of a half. Or another example might be, I'll do it down here, say the 7th root of 16, that's equal to 16 to the power of 1 over 7. All right. You'll normally be converting from this to this. Okay. Right, let's move on to the next bit. I'll just erase that so we give myself a bit of space. Now, a to the power of p over q here, a to the power of p over q is equal to a to b to the power of p, and then it's to the qth root. You'll often see it looking like this, a to the power of p to the qth root. And that can also be written as the qth root of a to the power of p. Again, p and q are integers, q is not 0, a is greater than 0. So maybe an example of this might be, say, 12 to the power of, say, 3 over 4. Well, that's equal to the 12 to the power of 3, all of it, to the fourth root. Or I could write it like this. I could write the fourth root of 12 to the power of 3. This here is to let you visualize how it can look using this particular terminology. I'd like you to get used to reading it like this. and see that the 3 here, because it's on the top of the fraction, is to the power of 3. So that's 12 multiplied by 12 multiplied by 12. And then this is the fourth root of all of that. Normally the ones you're going to see are going to be things like, there might be 27 to the power of a third. So this number here is going to be just 3, because 3 multiplied by 3 multiplied by 3 is 27. Okay. Let's see, what else we got? A to the power of minus p is 1 over a to the power of p. And a to the power of bp is equal to a to the power of bp by b to the power of p. And lastly, I just realised I'm 5 minutes just talking with the rules. So I want to get off these quickly and move on to the examples. Okay, let's move on to the examples. You might like to pause this for a moment. I came across it looking up surds, and there are some surds in it, as you can see. But can you place all of these within these particular, can you place them within whether these are natural numbers, integers, quotients, or rational numbers, numbers that can be expressed as a fraction, or these are reals but not quotients. In other words, these are irrational numbers, and then these are real numbers. Or/q means all the real numbers, but not the quotients, not the ones that can be expressed as fractions. So numbers like pi go in here, because it's a real number, but it cannot be expressed as a fraction. Okay, so pause the video, and maybe then just go through in your mind, or on a piece of paper, what all of these are, and then come back and press play, and see if you've got the right answers. Okay, here's the answers. So first of all, let's look at natural numbers. What are the whole positive numbers greater than 0? So just 8. Let's look at and all the others are not. Their x's would go in there. Integers, all whole numbers, and positive and negative, including 0. So 8 is, and minus 4 is. Okay, none of the others can be expressed as whole numbers. The quotients, the rationals, numbers that can be expressed as a fraction. But no, also it has a fraction a over b, where a and b are integers. Okay, a comma b are elements of z. They have to be integers. So root 5 isn't. That's a surd. 8 is fine because it can be written as 8 over 1. Minus 4 can be written as minus 4 over 1. And 3.5 can as well. That's a fraction. 3 looks like a fraction, but pi is not an integer, so therefore it's not a rational number either. The or/q, or less q, these are all the real numbers. So all the natural, and all numbers, naturals, integers, quotients, but the ones that are irrational, ones that cannot be expressed as a fraction. So the root of 5 goes in here because it's a real number, but it's not a fraction. And this one here is a real number, but it's not a fraction either. And they're all real numbers. Okay, right. Next page to look at some specific surd questions. Okay, here's the first kind of surd question I spotted. There's a c plus the root of d to be squared. Okay, so I'm going to write down c plus the root of d multiplied by c plus the root d. C by c gives me c squared. C by root d gives me c root d. And then I move down to here. Then move on to the next part. So root d by c gives me c root d, or d root c. And then root d by root d gives me d. So I add these up, I get c squared plus 2cd plus 2c root d plus d. I'll make this a better d. Okay, next page. Okay, question. You've got to show that the root of 98 minus the root of 18 plus the root of 2 is equal to 5 root 2. Without any further ado, if you type in root 98 into your calculator and hit enter, you're going to get 7 root 2. 7 root 2. Type in 18 into your calculator. Sorry, root 18. Root 18 into your calculator. You're going to get 3 root 2 minus 3 root 2 plus 1 root 2. And I'm going to get 7 minus 3 is 4 plus 1 is 5. So it's 5 root 2's. Without your calculator, what happens is, if I look at this root 98, for example, so if I didn't have a calculator, I could rewrite root 98 like this. First of all, you notice I've written all of the square numbers on the left-hand side here. 1, 4, 9, 16, 25, 36, 49. Then it'd be 64 and 81 and so on. And I want to find which of these divide into 98. Forget 1, of course, it makes no difference. 4 doesn't, 9 doesn't, 16 doesn't, 25, 36, they don't divide in. 49 does. So this can be written as 49 multiplied by 2. And that's equal to the square root of 49 times the square root of 2. And that's equal to 7 root 2. Your calculator does it for you, to be honest. It's easy. You're never going to go anything bigger than this. And you'll probably always be able to use your calculator during these exams as well. So QED. All right, let's express the square root of 8 as 2 to the power of p, where p is some rational number. Okay, so what I'm going to do is I'm going to convert my 8 first. I'm still going to leave the big square bracket on it, or square root, and 8 is 2 to the power of 3. And this bracket here, this square root sign means to the power of a half. So that's going to give me 2 to the power of 3 to the power of a half. And that's equal to, looking at my rules, 2 to the power of 3 over 2. Done. 2 to the power of 3 over 2. Okay, I had a look through the previous papers looking for surds. I didn't find any questions with where you had to solve using algebra. Okay, but you never know. It's on the course. It could come up. And they always tend to be quite easy as well. But if you do get something that has a p or a variable in it and you need to solve to find out what value of p would work, what I would do is you turn everything into the base power. So in this case, 3, because 3 to the power of 3 is 27. And 3 squared is equal to 9. So first of all, you can rewrite this as being 3 to the power of 3, 3 to the power of 3, and that's all to the power of p, times 3 to the power of minus 4, and that's equal to 3 squared to the power of 4. I can multiply that out. That's 3 to the power of 3p times 3 to the power of minus 4. I've left out the brackets here, the multiplication. I might do that though. And that's equal to 3 to the power of 8. Okay. Now, I decided to, I want to get rid of the 3 to the power of minus 4. So I converted it. 3 to the power of minus 4 is equal to 1 over 3 to the power of 4. So I wrote it like this. So 3 to the power of 3p divided by 3 to the power of 4 is equal to 3 to the power of 8. Okay. Then I brought it up here. And I told the examiner where I was going. I put my little arrow coming up to say I'm continuing on this part of the question. Otherwise, I've no idea. If I'm examining this, I don't know. So do let the examiner know where you're going. I put a little line in as well to separate the bits. So now I've got 3 to the power of 3p is equal to 3 to the power of 8 multiplied by 3 to the power of 4. 3 to the power of 4 by 3 to the power of 8. So 3 to the power of 3p is equal to 3 to the power of 12, because I add these. And that means that 3p is equal to 12. Because the indices are equal to each other, because the bases are equal. So 3p is equal to 12 and p is equal to 4. If you're asked to verify, you will say, you will type in 27 to the power of 4 multiplied by 3 to the power of minus 4. You'll get the answer to that, which is 6567, where it was, 6561. You'll get that. And then you check that 9 to the power of 4 gives you the same thing. And if it does, you've then verified it. So to verify means you substitute your answer back into the original equation and to prove it.